Hey guys, let's continue from where we left off. We looked at the driver program in detail. We are also now familiar with the input and output format and writables. In this lesson, we'll look at the mapper program, reducer program, and execute the Mapreduce job in our cluster. Let's now move on to the mapper. So here's my mapper program, maxClosePriceMapper.java. Before we talk about the mapper program, let's recap what is a mapper and what is a map face. So your data set will be divided into multiple parts, and we call the parts input splits because input split respects logical record boundaries. Each mapper then processes an input split. Each mapper will be called multiple times depending on the content of the input split. Meaning, if you have 100 records in the input split, each mapper will be called once for each record. So in our case, it's going to be 100 times. The output of the mapper for each record will be a key value pair. A mapper for a given run can choose not to write an output. For example, if it is processing a bad record, it can choose not to write a key value pair as output for a specific run processing a record, and that is okay. There will be one or more mappers in a Mapreduce job, and the number of mappers is determined by the number of splits. Make sense? Let's now go look at the program. In our dataset, that is our stock dataset, each line is a record to the mapper. So a mapper will be called once for each line in the input split. Let's talk about the output from the mapper, that is the actual output. Right? So in this problem, we're trying to find out or calculate the maximum closing price for each stock symbol. This means that we have to group the records by symbol so that we can calculate the maximum closing price by symbol. So we will output the stock symbol as the key and close price as the value for each record. Make sense? So that's going to be our key value pair. Our key is going to be the stock symbol and the close price will be the value for the key value pair. Okay, we now know what is going to be the map's input and what is going to be the map output. Let's look into the program. We'll extend the mapper class to make our class a mapper. Make sure you have the right import. So the import we are using here for the mapper class is org.apache hadoop mapreduce.mapper. The older version of Hadoop library will have mapred instead of mapreduce as a naming convention for the package. Whereas the later version or the latest version will have Mapreduce as a naming convention. Make sure you have included the Mapreduce to avoid any class conflicts. Look at the signature of the mapper class. There are 4 parameters listed here. The first 2 parameters dictate the input to the mapper as key and value. The third and the fourth parameter tells us the output key and value types from the mapper. So the input key to the mapper is of type long writable and the input value is of type text. The output key from the mapper is of type text and the output value from the mapper is of type float writable. In our program, we have to override the map method because this method will be called for every record that is passed to the mapper. The first 2 arguments of the map method varies based on the input format that defines your dataset. The second parameter, what we have here, makes sense, right? The type is defined as text, which is the actual line from the file. The first argument, however, is long writable, but what does it really represent? The first argument is the byte offset of the record within the file from the beginning of the file. So this argument, in this case, is not much of importance to us. So we will just ignore the argument when we are processing the record, because we are more interested in the second argument, which is the actual record from the file. The value that is passed into the map method has the actual stock record. So if you go back to our dataset, this is our dataset, right? So every single line is a record for us. So for example, in one of the mapper runs, this record will be passed to the mapper. As you can see, the record is delimited by comma. So the first thing we'll do is take the value object and convert it to a string so that we can manipulate the record as a string, which is much easier. We also know our data set very well. And here we are looking to extract the symbol and the closing price from each record. We know by looking at the data set, the second column has the symbol and the 7th column is the closing price. Since the index of the column starts from 0, we have to use 1 and 6 to extract the symbol and the closing price. Now we have two values from the record that we are most interested in. We know that the output of the mapper should be a key value pair. In our case, the symbol will be the key and the closing price will be the value. But how do we submit the output from the mapper? We will use the context object to set the key value pair. That is it. From here on, Hadoop will take care of the output. The output along with the other key value pairs from other mappers will be sorted and partitioned by key, which will then be copied to the appropriate reducer. Then, at the reducer, the output from several mappers will be merged. The values for a key will be grouped, and the input to the reducer will be a key with list of values for that key. The reducer will be called once per key. Before we take a look at the reducer, let's recap what a reducer is. A reducer or a reduce function is going to take key value pairs from multiple map functions as input and reduce them to output. The keys are grouped with values, and the reduce function is called once per key and its values. So for example, in our case, the key value pair is symbol and closing price. So the key value pairs from all the mappers will be grouped together by the key, in this case the symbol. The reduce will receive 10 records to process, one for each symbol, right? So each symbol will have a list of values, the values being the closing price. Make sense? So in your Mapreduce job, you can have 0, 1 or more reduce function. So how many reducers you can have for your Mapreduce job? You can have 0, 1 or more reducers. In our case, we definitely need a reducer. In some cases, you may not need a reducer because you won't be reducing anything. You can output the results straight from the mapper. In some cases, reducers may not be necessary, but in our case, clearly, we need a reducer. Now let's look at the reduce program. So here's our reduce program. Having seen the mapper already, following the reducer will be much easier. First, start by extending the reducer class. You have to specify 4 type parameters. The first 2 parameters define the input to the reducer, and the third and the fourth defines the output from the reducer. Next, override the reduce method. This will take text as the key, which is nothing but the stock symbol, and an iterable list of float writables, which is nothing but the list of closing prices for that particular stock symbol as arguments. Once you have the list of closing prices, it is easy to calculate the maximum closing price. So you simply iterate through the list and calculate the maximum. Use the math.max function to compare two values and find the maximum closing price between the two. Finally, once you have the output, simply submit the output by calling the write method on the context. Now we have the program ready. It is now time to run this Mapreduce program as a job in our Hadoop cluster. So to do that, we need to export this project as a runnable jar. Let me show you how to do that. So just right click on the project. It's very simple. Click on export, jar file, next, give a location. You can save it anywhere and hit finish. That's it. Your jar file is now saved. So I have saved in this location right here. To run this jar in our Hadoop cluster, you need to first copy the jar into our Hadoop cluster. Since I'm using Windows, I use a software called WinSCP, which is a free software. You can download it from the internet. So open the software, hit new, give the host name, which is our IP address for the cluster, give your username. You don't need to give the password, but you need to give the private key file which was provided to you. Okay? And save it for future reference. So I've already saved my credential, so I'm going to use that credentials to open up a session. I'm going to use this connection right here, login. So look at the lesson notes for the exact location of the jar file. I have the jar right here, and I also have a readme file. So open the readme file, right? You can either view the files using WinSCP, or you can also use the Linux terminal, whichever is comfortable for you. There you go. You see the jar file and the readme file. So you can open the readme file from here as well using VI. It's totally up to your convenience. So let's look at how we can submit the job. Okay. So the first thing is the input location. I've already uploaded our stocks dataset to this HDFS location right here, user hirw input stocks. This data set is about 400 MB. Okay. The output location that we're going to write is output Mapreduce stocks. See, we don't have a slash in front, so which means this location is going to be relative to the user. It's always a better practice to delete the output directory first, because if the output directory already exists on HDFS, when you run your Mapreduce job, Hadoop will complain that the output directory already exists. So you may want to clean up the output directory if it's already there before you kick off a Hadoop job. All right, the next is the Hadoop command to actually run the Mapreduce job. Use the Hadoop jar command followed by the jar location and give the class name to start. That is the class which you want to first execute. So we are giving the driver program here because we have the driver program has all the information to submit the Mapreduce job into your cluster. Followed by two arguments. The first argument is actually the input location, that is the input location of the stock dataset. And then the second argument is the output location where you want to write your output. You may want to note that we are using Hadoop to execute the jar file instead of using Java to execute the jar file, because using Hadoop conveniently adds all the Hadoop libraries to the class path. If we decide to use Java to execute, we can do that, but then we have to manually specify all the classes that are needed to be added to the class path. So using Hadoop is a much better choice because it's convenient. So the first thing I'm going to do is I'm going to clear the output directory, just to be sure. All right, so there's no such directory, so I'm good to go to run my Mapreduce job. You can see the progress of the Mapreduce job because it's going to print the information of execution on the console. The first thing you will see here is the number of splits for. I said it's a 400 MB data set. With 128 as the block size, we resulted in 4 input splits. So which means we would need 4 mappers. There you go. We have processed 400 MB in just a matter of seconds. Okay, so let's look at a few more things before we look at output and a few other things, right? So you will see a lot of information that is displayed on your screen. You can also see the progress that is being made. The map and the reduce started with 0%, then map went to 75 to 100, and then map and reduce finished with 100% each, right? So the next important information is, of course, the job completed successfully, right? And you're seeing few counters. Counters are useful information to see what is going on when you execute a Mapreduce job. Here are some key information that you want to look for. The first one is launched map task. So we have launched 4 map tasks and we have launched 1 reduce task. And the number of input records to the map, which is about 7,461,349 records. So we processed 7 million stock records. And the map outputted the same number of records because for every record, we extracted the symbol and the close price. And the next important thing is reduce input groups, which is the number of records sent to the reducer. In this case, it's 836, which means we had 836 unique symbols or unique stock symbols in our data set. And the reduce output is also the same because for every symbol, we want to know the maximum close price. So that is it. So those are some of the key important counters you may want to look at. But there is much more. Counters are very helpful, especially when you had a bad executing job. When the output doesn't match your expectation, you can always refer to the counters and see how many records are processed, whether there are any issues, and things like that. Since our Mapreduce job is now complete, we can now actually look at the output. So I'm just printing the output on the console. So it's 836 records, as you can see. Each symbol has a closing price. And this closing price is the maximum closing price of each symbol. So now we were able to successfully execute a Mapreduce program to calculate the maximum closing price by symbol. And here's our output, right? There's one more thing I want to show you, and then with that, we'll end this lesson. So you can also look at the status of the Mapreduce job as it's executing in your cluster using this URL right here. So this URL is specific to this application, that is specific to this MapReduce run because it has the actual application ID. So copy this URL and paste it in your browser. You can see all the information that you saw on the screen in this URL. So some of the important information that I want to show you is basically the number of maps that ran, which is 4, the number of map attempts and reduce attempts. There are no failures and no mappers or reducers were killed during execution, which is a good thing. The state is success, which we know already. So let's click on the 4 mappers, as you can see. So these are the 4 execution, each execution successfully completed. You can also look at the attempt number and also look at the node in which the mapper was executed. That is it. We successfully executed our first MapReduce job. With that, let's wrap this lesson. See you in the next lesson.